This video about graph analysis is going to go over the same concepts that we covered in the last video. The difference is how the information is given to you. In these questions, you're given a function g defined as the integral of f, and over here you're given the graph of f. So we need to make that connection between g and f. On part A, we're asked to find g of 10. And what that means is I go to function g, which is up here, and where I see the x, I'm going to replace it with a 10. Now where that x appears in that function is that upper limit. So I just replace that upper limit with a 10, and now my job is just to evaluate this integral from 4 to 10 of f. And over here what I have to work with is the graph of f, and we know that an integral just means area. So I'm going to look at the area from 4 to 10, and I've already found those areas for us. From 4 to 8, that area is a 4 above the x-axis, so it's positive. And then from 8 to 10, the area of that little triangle is 2, but that's below the x-axis, so I need to subtract it. The value of my integral is 4 plus a negative 2, or just 2 is my answer. When I do g of negative 10, it is the same idea. Where I see the x in my function, which is the upper limit, I'm going to replace that with a negative 10. When I take a look at this integral, I notice that my limits are reversed, but to get them in the correct order, which is to have that lower limit be the lower number, I just introduce a negative in front, and then it's just what I did before. I need to find the area from negative 10 to 4, and these two areas from negative 10 to negative 6 and from negative 6 to 0 are trapezoids, so you have those areas there. And then from 0 to 4, I have a semicircle. Anything above the x-axis, which is the 36 and the 2 pi, I count as positive, and anything below the x-axis, which is that 14, gets counted as negative. And I find that my final area, my final integral value is negative 22 minus 2 pi. You would be fine to leave it this step above if you wanted to, or you could do the calculations and come up with my boxed answer. Remember, if you're going to choose to do calculations, they must be done correctly. Otherwise, just don't do them. In part B, I'm asked to find g of negative 6 first. I handle that just like I did in part A. I replace the upper limit with a negative 6, but because I know they're going to be backwards, I went ahead and as I wrote it down, I wrote them in the correct order, and I remembered to put that negative out in front. And then I just look at the area between negative 6 and 4, which is negative 36 plus 2 pi. It's all above the x-axis, but because of that switching of the limits, it puts a negative. You could distribute the negative if you want, or you could just leave it as the answer above. The next part of the question wants g prime of negative 6. This is asking me to do the derivative of the integral. The fundamental theorem part 2 told us that those are inverse operations, so they just cancel each other out. And the way you handle that is you just take your upper limit and you plug it into your function. And that establishes this relationship that g prime of x is f of x. In other words, up here in this picture, I am told that this is the graph of f, but it really is the graph of g prime of x. So when I'm asked to find g prime of negative 6, I just need to find f of negative 6, that is the function value at negative 6. And I can see that on this graph at negative 6, my value is 0. It is critical that you establish this relationship that says g prime of x equals f of x and write it on your paper. The next part of the question is asking me for g double prime of negative 6. So starting at this relationship here, I'm just going to go one more derivative out. And that tells me that g double prime is f prime. What I am given to work with is the graph of f. If I want f prime of x, and I'm looking at the graph of f, all it's asking me for is the slope. So at negative 6, I look and I just calculate the slope on this line right here, and I can see I go up 4 over 1, so my slope is a 4, so my g double prime of negative 6 is 4. Part C is asking where g has a horizontal tangent line, and I know that g has a horizontal tangent line where its derivative g prime equals 0. What I established in the previous part of this problem is that this is the graph of g prime. Even though it was labeled as f, I made that connection that it is really g prime. So I'm looking literally where this graph equals 0. And I see it equals 0 in 1, 2, 3, 4 places. So before I read the rest of the question, I'm just going to list those x values out. I am now asked to classify each one. So at x equals -6, I can see my g prime graph goes from negative to positive. That makes x equals -6 a minimum on the graph of g. At x equals 0, I see my graph does not change signs. It stays positive, coming into 0 and positive, leaving 0. That means that it is neither a max nor a min at x equals 0. That same idea is happening at the 4 as well. My graph of g prime is positive coming in, it's positive leaving. There is no sign change. Therefore, there is no max or min. And then at x equals 8, I can see my derivative graph goes from a positive to negative, indicating that we have a max. Just a reminder, when you do these justifications, you have to make sure that you give the name of the graph, in this case g prime. Because I know that f and g prime are one and the same, you could have, every place I said g prime, you could have said f, and that would be just as good. In part D, there are some key words that tell me what I need to do, and those words are absolute, max, absolute, min, and this closed interval, which is also indicated by the brackets on that interval. And what those are telling me to do is to do a candidates test. To find my short list of possibilities, I'm looking for these on the graph of g, so I need the critical points of g, and that is where g prime equals 0. Because I'm looking for a max or a min, I'm going to throw in here I need a sign change as well. I can see from my graph that that occurs at -6 and again at 8. I don't have to list the 0 and the 4 because there's no sign change, so there's no way they could be maxes or mins. We also learned that those maxes and mins could occur at endpoints as well. So this is going to give me my short list of possibilities. My critical points, the -6 and the 8, and my endpoint of -10 and 10. What determines which of these is the absolute max and absolute min is its value. And I'm looking for the absolute max and min of g, so I need g of each one of these values. G of -6, I actually found in part B, so I'm just going to pull that answer down. G of -10, I found in part A, so again, I'm just going to pull that answer from part A down. G of 10 I found in part A as well, so the only one I have to work for is G of 8, but I'm going to find it just like I did in the previous parts. Going to replace that upper limit with an 8, look at the areas, and I get that answer as 4. And then I just answer the question. The highest of these values is my maximum, and as I'm looking at all of these, that's my max value, so I state it here. And it's asking for the absolute max and min values, so I want to make sure I give that value is actually what's answering this question. And my minimum value is my smallest value, and I can see that that is the -36 minus 2 pi. And it occurs at x equals -6. The next 3 questions are going to ask me about characteristics on the graph of g. So it's important that you pay attention to the graph who you're being asked about. If I want to know where g is increasing, well, I'm going to do a fun chart with a slight twist, and it's going to be a gun chart. If I want to know where g is increasing, then I'm interested in having g, g prime, and g double prime over here. So I can see that g is increasing where g prime is positive. And I established on the front side of this page that this is the graph of g prime. So I'm looking for intervals where this graph of g prime is positive, and that's occurring on all of those red pieces. So g is increasing on -6 to 8 because g prime is positive. The question is also asking where is g decreasing, and I see g is decreasing where g prime is negative. And the negative parts of this g prime graph, there are 2 intervals, one that goes from -10 to -6, and then again from 8 to 10. And my reason is just because g prime is negative or less than 0. Again, make sure that you reference the graph by name here, g prime. Because I've established that g prime and f are one and the same, I could have called it f instead. Question F is asking where g is concave up. G is concave up where g prime is increasing. And I see this graph is increasing on 3 intervals. And g is concave down where g prime is decreasing. And I have decreasing on 3 intervals as well. So I just list my intervals out, and my reason is because g prime is decreasing. And again, you could call it f if you want to, because you've already established that relationship that f and g prime are one and the same. Part G is asking me to put two characteristics together. I know that g is increasing where g prime is positive, so that's 1. And g is concave down where g prime is decreasing. So that's the other characteristic I'm looking for. So my g prime graph is above the x-axis and decreasing in 3 places. And I just list those 3 intervals. And my justification is just what I was looking for. G prime is positive and decreasing. Part H is asking for various g double prime values. If this is the graph of g prime, then I know g double prime is wanting me to pay attention to the slope. G double prime of 5, I go here and I look at 5, I take a look at my slope, and I just count it out, up 1 over 1, up 1 over 1, so my slope, my g double prime of 5 is 1. G double prime of 4, I take a look here, and at 4 I have this corner point, and I know a graph is not differentiable at a corner point, therefore g double prime of 4 does not exist. And my last one is g double prime of negative 3. Here at negative 3, my graph is flatlined, therefore it has a slope of 0, so g double prime of negative 3 is just equal to 0. In part I, I'm given a function h that's defined as g of x squared plus 1, and I have to find h prime of 1. I'm going to start by finding h prime of x. I see that x squared plus 1 is inside of that g function, which means I have to chain rule this. So my h prime of x, derivative of the outside is g prime. Leave the inside alone is the x squared plus 1 times derivative of the inside, and that gives me my derivative. And to evaluate at 1, I just turn all these x's into 1s. This becomes g prime of 2 times 2. I'm looking at the g prime graph above, and I can see that g prime of 2 is just 2, so this just becomes 2 times 2, which is 4. In part J, I'm given another function called k, which is defined to be g of x divided by 5x. And I'm asked to write an equation of a tangent line at x equals 8. So I know I need k of 8 for my point and k prime of 8 for my slope. So for k of 8, I'm just plugging an 8 in for all of those x's. G of 8, I'm actually going to pull from part D. And that gives me my point 8 1/10. And then to find my slope, I need to do the derivative of k, which is going to involve a quotient rule. So here's my bottom function times derivative of the top minus the top times derivative of the bottom, all over that bottom function squared. And just one thing to watch for, make sure that this entire denominator is being squared. If you were to write it as 5x squared, technically that would be incorrect because you're only squaring the x and you need to be squaring the 5x. I now plug my value of 8 in for all of these x values. And the last thing I need to do is just pull in my g prime of 8 and my g of 8 values. For my g prime graph, I can see that g prime of 8 is 0. So that's just going to zero out this first part. And then g of 8 is the 4 times 5. And I just continue on and I get that my slope is negative 1 over 80. And with this information, I can write my equation y minus 1/10. You can use 4 over 40 if you don't want to simplify it, equals negative 1 over 80 is my slope, and then x minus my x value. In part K, I'm asked to evaluate this limit. The most basic form of evaluation is to take your 2 and to plug it in. And what happens is I get 0 over 0, which is that indeterminate form. Remember, when you use L'Hopital's rule, which is what I need to use to get myself out of that 0 over 0 situation, I need to express the limit of the numerator and the limit of the denominator separately. So I say the limit as x approaches 2 of the numerator is 0. The limit as x approaches 2 of the denominator is 0. I end up with this indeterminate form, therefore I'm going to use L'Hopital's, and now I go ahead and use it. And the way you use L'Hopital's rule is you do the derivative of the numerator. This first term, I need to do a chain rule, so derivative of the outside is the g prime. Leave the inside alone as the 3x times derivative of the inside, and the polynomial's derivative is just 2x minus 7. And then I retry my substitution, so I'm going to take my 2, I'm going to plug it in. And now I'll be able to evaluate this limit without getting the 0 over 0 situation. When I plug the 2 into this function, I'm going to look up g prime of 6 times 3 over the negative 3, and I get a final answer of negative 2.